All right, today we're going to take a look at a kinematic problem with constant acceleration. What we have here is a lawnmower starts from rest and accelerates at a constant rate of 31 meters per second squared in the positive direction along the straight line and reaches a velocity of 62 meters per second. We're going to try to find the displacement. Now it helps to draw a picture in these problems. So I draw my lawnmower here. And then it's starting from rest. So my initial velocity is 0 meters per second. It accelerates at 31 meters per second to the right, squared. And then it has a final velocity of 62 meters per second. So what we're trying to find is the displacement. So I've labeled all of my variables here. Initial velocity, acceleration, final velocity, and what I'm looking for. So it may help you to actually write it out to the side here. Again, that way you can see your variables easier. So I have initial velocity equals 0 meters per second. Final velocity equals 62 meters per second. Acceleration equals 31 meters per second squared. And I am looking for x. So now I need to find an equation that uses all of these variables to find x. And I'm going to pick velocity squared equals the initial velocity squared plus 2ax. Now we have to rearrange this for position here. When we rearrange this, we get x equals final velocity squared minus initial velocity squared over 2a. And at this point, it's just some plug and chug monkey math. I plug in 62 squared minus 0 squared over 2 times 31. And when I do this, I get that the final answer ends up being positive 62 meters. So this means that it has moved 62 meters to the right. Notice that we managed to solve this whole problem without having any time given to us. If you wanted, you could have actually solved for time first and then used a different equation, but this way is much faster, much more efficient. Hope this helps.